Okay, let's go. I'll make this quick, so pay attention. First, we need a terrain. For me, I'll use my terrain generation. You can use wherever you want. I'll go with 512 by 512. I'll add a noise layer. I'll zoom out, maybe add some octaves. Control the scale, let's make it 2. And the size will be 100 by 100. Maybe the size of 1.8. Okay, maybe one more octave, and I'll use the simulation for the erosion. I'll use 500,000 droplets, and maybe set this to 1080. I'll increase the droplet lifetime. I'll set this to 0.8 and maybe get more points. So let's set this to 800,000 and maybe put this to 3. Okay, seems like a decent enough terrain. Go to texture, looks nice. This add-on is not currently available. It will be available soon. So we'll duplicate our terrain. We will remove this, turn off the add-on, and remove this. Let's rename this to T for terrain. And let's add a geometry node. We don't need this add-on anymore. Okay, here is our geometry node setup. Let's call this points. And we need a spreadsheet. I will go to spreadsheet. And now you can save. Okay, so first things first, we need to use our own grid. First, I'm not working with this much resolution, and this grid maybe it's not perfect, or you have a grid that is triangulated. You need a perfect grid for our use. So let's get the bounding box. Let's add a reroute and a group. Let's make an output, and we will separate XYZ. We'll also separate XYZ here. Turn off the radius because we don't need it. You can subtract the scale from this scale, and also subtract this from this. You need to invert this because this is the maximum. Now we need our grid. So grid. This is the size X and size Y. And this grid will be connected here. So let's call it dot grid. And we need to floor this. So let's make floor and one more floor. Okay. And let's divide these. I will divide, and I will divide again, and we'll divide by 1, the default. Let's make this an input. Let's name it size, and it's connected over here, also connected in here, or not the size. This needs to be res or cell size to be exact. So we'll divide the scale, which is 100, by our cell size, which is 1. So we get 100 vertices, and we need to add 1 to both of these. So add 1 and add 1. So we get 100 edges, and we need to store some things. So store named attribute, store named attribute, and another store named attribute. You can use this to align the nodes. First one is the grid resolution, which is an integer, and the grid scale, which is a float, and the grid cell, which is also a float. So the grid resolution, which is this, and the cell size, which is this, and the grid overall scale, which is this. This may not be correct, but we'll get to that later. We will check it when we are testing. And the last thing we need of this is to take our original input, add a raycast node. So this is our target, and we'll raycast from our position. We will move up by 100 meters, or maybe just move down by 100 meters, and we will shoot up. And we will shoot 500 meters or 600, doesn't really matter. And we will scale elements on this, and the scale needs to be 1.001. So just make it slightly bigger so the raycast doesn't fail on the edges. And we want to set the position. If we're hit, we're gonna go to the hit position, and now we have our decimated grid with custom attribute save, which is the first step in our effect. Okay, the next step is making a custom sample nearest. So let's make this 4 meters. Okay, and to make my life easier, I will just move this so that it's always on the positive side. That should make things a lot easier. So set position, and after this we want to take the named attribute, the attribute named grid scale, and we want to set position, and this position needs to be combine XYZ, and we want to scale by 0.5, and we want to move it, as you can see, so it's only on the positive X and the positive Y. This should make our life easier when we want to set the sample nearest. But why use it? Let's make our life harder by first we need to grab an empty for testing. So I'll grab this circle or sphere. Let's get it over here, get its location. And first things first, let's separate XYZ. And first things first, let's move it. So add, and we want to be moving it by a named attribute, and this attribute is called scale. And let's go to a combine XYZ, and also scale by 0.5. Okay, now if I view this, so yes, and this is not working, needs to go to 0. So why is it not going to 0? So this is 0 and this is 0. Okay, So 0 over here. And this is the positive side. That's how you know it's working. And now we need to floor both of these. So we're basically gonna turn the position into a nearest index. So let's floor both the X and the Y. So now it's 0. And when I go over here, it should be 1. So we will be dividing this and this. We'll divide both of them. So add, divide by our grid resolution, which is, where is it? Or the cell size. So name attribute, grid cell, will divide, and also here. So right now, when I cross this threshold, it's 1. And we may need to floor these afterwards. Okay, let's floor. And the floor over here is not needed, so that's a 0, and it gets to be 1 when I cross this threshold, and this is a 0, and it gets to be 1 when I cross this threshold. So that's sweet. Okay, next step, we will need to multiply these. So this one, the x-axis, needs to be multiplied. So if we compare it to the index, this is the index, so it needs to be 26 over here. So this one needs to be multiplied by 26, which so happens to be our grid resolution. So let's multiply this. And after flooring, this needs to be an integer, so add integer math. Let's just multiply by this, and also this one we need to, this one is not multiplied, this one is added directly, and the result of this should be our nearest index. So when I am, let me just pin these. So I am in cell 0, I'm in cell 26, I'm in cell 1, cell 27, cell 3, or cell 2, cell 3, 2, 1, and so on. Okay, this needs to be a node. This node takes a location, and it gives us the cell. And from the cell, or the cell is the bottom nearest index, which is this one. We need to find this one, also this one, and this one. So for this one, if you compare it, okay, you can add another window like so. And when you do this, if you enter inside your node, it will stay active, the viewer. So this is our first cell, and if I check the index, we need to get 26 over here. So we have a 0, we'll just add, or maybe integer math, add 26. So this is the first neighbor. So this is the cell, and these are the neighbors. This is the first one. This is the second one. So this is the first. This is the second. After we add 26, we have this one. And let me activate my viewer. So the first one is 0. The second one is 26. The third one needs to be this one. We subtract 1, and for the last one we have the resolution and we add 1 to it. And this one is to be 2, this one 3, and this one is the 4th one. So that's 3 and that's 4th. So let's just check. This is our cell. Okay, let's test that. So here we display the index. So 0, 1, 27 and 26, and we have 0, we have 26, we have 25 and 27, 0, 26, 25 and 4. Okay, one of these is incorrect. We need to take this one and add to it. So it's always a good idea to debug your work. So 0, 1, and this one should be 26 and 25. If we check 26, this one is 27. So we need to add 1, not subtract. Okay, so 1, 26, 27 and 4. Okay, and the ordering needs to be, let me check the ordering of these. So 0, 26, that's 0, that's 26, and this one is 1, 27, so that's 27 and 1, they're inverted. So let's just flip these. This goes in here, this one goes in here, and also let me do this. Okay, now we're golden. So this is nearest cell, and we'll use that to find some cool stuff. So next step is finding the nearest interpolated attribute, and first we need to store an attribute. So what I'll be storing is the Z position. Okay, I'm not liking this at all, so let me go to edit mode and just bring it down a little bit, maybe something like that. Okay, let's store named attribute, not this node. Store named attribute. We want to be storing the position, and we want to separate the XYZ, and we definitely want to store the Z. Okay, let's call it grid/height. Okay, now we want to sample the height for each point, even if the point is in the middle, and then we'll do our simulation. First need to get the data flowing, so let's add a reroute and Control G, and we call this node bilinear interpolation, and we'll get the first cell, so sample index, not this one, evaluate at index, set this, and we want to evaluate the float, and the float is a named attribute, and that's the attribute we want to be sampling. Okay, so the attribute of the first point and the attribute of the second point, this will be mixed, and it will be mixed based on the distance between these points or my original location. Let me just separate XYZ, and again I will get the X. Let me get a viewer over here. Why did I make this into a group? Let's just ungroup it. This makes it so much easier. And this is our X location. We also need to do the correction step. Okay, it's working. And we basically want a mix between 0 and 1 over here. So it needs to be 0, and here it needs to be 1. Okay, now it's 0, now it's over 1. So let's just floor. Where is the floor modulo? And by a named attribute, which is the cell size. Okay, 0 to 1, 0 to 1. This is 0, this is 1, this is perfect. Perfecto. So this is 3. Why is this 3? Okay. So this one's 4. Okay. So now it loops over 4. We may need to be dividing. Okay, I just need the reminder. So divide. And okay, do we need the fraction? Add divide by the grid size. How much is the grid size? It's 4. Let's divide by the grid size and get the fraction of this. 0.7. This is 0. When it gets here, it's 1 or almost 1. It's never really 1, and that's just perfect. Okay, so that's the X1 is done. And for the Y, I guess we'll do the same thing. So for the Y, so it's 0 over here, then it becomes 1, then a 0. Okay, that's just perfect. And this is the mix between these cells. So let's call this. Okay. So X factor, and this one is the Y factor. Okay, this is extract factor, and we'll use the X factor to mix between those. Okay, and we have these 2 points, and we'll use, guess what we'll use? We'll use the x factor again. You know why? Because we have this first point and the second point and this point and this point. So these are the first 2 points and we want to get the value between them, and these are the second 2 points and we want to get the value between them. Let's say our point we want to sample is here, so we mix those with those using the y factor to get the interpolated value between 4 points, and that's the whole logic. And now we're going to mix these using the, you guessed it, the y factor, and that should give us our interpolation. So the attribute, let's go with g height, and maybe for now I'll sample a random value, set this to a boolean, and let's check. So this is a boolean, so we have 2 false, and this let's look for an interesting one. Okay, this one, we have true, 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 and a false. And when we interpolate, we should get 0.7, and we come closer to the false, we get a 0, closer to the true, we get 1, closer to the true, we get 1, closer to the true, we get 1, and the false get a 0. So we are successfully interpolating using this test object. Okay, we don't need this anymore, and let's make this contained inside our node that is called bilinear interpolation. So sample nearest grid attribute, or just sample nearest grid, and we definitely want this to be outside, and we definitely need this, and let's call it result. Okay, it's already called result, and we definitely need to put a point in here, or maybe we'll use that later, but we have all we need. And now the fun part, the simulation. So let's just increase the resolution. Let's put this to 1 and maybe 0.5. Now I'm done. How many points we have? Okay, why do I not see my mesh data? Should be seeing it now because it's not selected. Okay, so I have 40,000 points. Okay, and the height is already stored, and we are going to simulate. So just put this to a simulation, and we'll make a simple position-based dynamic simulation. So the first thing, store named attribute. We want to store the delta time under the name simulation dt, and this one is simulation velocity, and let's say vector. But before the vector, we need to start the initial position. So initial position, position initial. Let's store the position, and for the velocity, we take a named attribute, named simulation velocity, and we add to it our vector, which is gravity negative 9.8, and we scale that by, you guessed it, named attribute the delta time, and we set position and we offset by the velocity scaled by the delta time. That would be all for our initialization step. So let's call this simulation dash init for initialize, and we definitely don't want to use this more than one time, so put a dot on it. That's always a good practice. And we need to recalculate the velocity, so make another group. Let's call it velocity. So simulation velocity update, and this need to be small, so velocity update, and we need to add a dot. We're not going to use this more than once, so store named attribute. We are storing a vector and it's called simulation velocity, and we get it by the position. We subtract the named attribute called the position initialize, and we will divide this by a named attribute called the delta time, and we'll scale this by 0.98. This is just our drag. So from our original position, go to our current position, which is aka the velocity, and we divide by delta time to get it in seconds. It doesn't depend on frames rate anymore. And if we play this, what's happening? Okay, something is not correct. Okay, you see, this is the problem. Always connect your attributes, not the exist socket. That one was a quick one. So now it falls and accelerates, but it falls relatively. We'll need this node now because we will make our constraints. So let's make this dot cons, and in our cons we will use this. So let's copy it, put it inside, and you normally want to, let's first convert these 2 points to 2 points, and we don't need the wireframe. The position, let's set this to 0.1 meters. We will simulate all these points, which are 40,000 points, and you might be tempted to just say proximity, and for now let's just set position to the nearest face. You can see this 7 FPS, and we're a long way from our million, so this is not gonna work. Instead, we don't need to sample the height because the height is already stored. So come over here, take the position, and in our constraint we'll take the point position. Remember, this turns the position into an index and the index into the nearest attribute, and it gets the attribute regardless of our z, and also here regardless of our z. So it's not affected by the height of the point, it's only affected by the position. So let's say I have a point in here, and okay, this point will ask in which cell am I. They will tell it, it will ask its friends. I'm in position, for example, 35, so I am in cell 35. and in the cell 35 I'll find my nearest cells, which are the left and the up and the down, and from those I'll find the nearest height, and that is the height that I cannot go below. So we will set position, and we will take the position, we'll separate XYZ, and then we will combine XYZ. So the X and Y, we won't play with those. It's the Z that we want to change, and we want to take the maximum of this and this. Let's see if this works. Okay, it doesn't. So the minimum, okay, the maximum, maybe I don't need the maximum. So this one less than this one, we will switch from this one to this one. So if my position is less than the position of the cell or the height of the cell, so if my height is less than the height of the cell, set my height to the height of the cell. Okay, they're not moving, and it's time to check Y, which is the fun part. So is the height correct? So if I set this height, okay, it's correct. And let's go to add, let's subtract from our position, maybe add this as an offset. Still no. Okay, there was a problem here. Let's scale this by 0.999, 4.9, 0.1. Okay, it's staying up. Okay, last time what I did was okay, last time I've done this differently. I guess I stored the normal as well. So sample the nearest vector, and let's sample the grid normal. And we can easily update our node to make it output a vector by simply converting this to a vector, this to a vector, this to a vector, and this to a vector, this to a vector, and this to a vector, and also this to a vector. So this one is 2, this one is 2, there's 1, and there's 2, and the output, we also need to change this to a vector. Okay, so it should be all working, but for our normal, and from the normal, okay, so from the normal we want to take the velocity and we want to cross product it with the normal and see if that works. Let me just reduce our simulation. And we'll set this to 1. Okay, let's get a point on a slope, which is this one. Okay, this is the nearest normal, should be. Okay, the nearest normal is working fine. And I have, you know what, we can skip this step actually. We're gonna add it in a different way. So if I have a vector that is pointing down and I need it to point down but only cross product with this vector, so it doesn't pass the normal. So if this is my surface, this is my normal, and I have a vector that goes down over here, I want this vector to basically do this. Okay, that's the idea. And these are always, it's best to do this, instance on points. I want to instance a line, so curve line, and I want to align rotation to vector, and this is my vector, and the length of this vector will be controlling this. So turn this to a group. This is just for debug. Serialize instance output and connect the vector. Also connect the vector. And now when you go to these points and you're scratching your head, where is my vector? So we just put this over here and you join these like so. So maybe the scale, add, multiply. You need to control the scale of the vector. Right. For some reason, these points now don't have vectors. Why is that? They were just working. Oh, I'm not connecting this. Maybe that's this. Maybe that's why. They were just working. What the hell? Okay, vector, 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 vector. Sure, this normal works, and go inside our constraints. Okay. It was just working. What happened? So anyways, you can view your normals just like so. These normals are incorrect and we need to figure out why. Okay, maybe this is broken, but why would it be? This over here, connect the position, and let me view my normals. So this one works. So after converting to points, it's working. So what's happening inside my node group? Okay, now it's working for no reason. Well, anyways. So when I view this, it doesn't work. Okay, this must be a bug. Anyway, we can do this outside if you want. Actually, you can remove this constraint completely. Oh, because I'm offsetting my mesh, that's why. Okay, it's not a bug. I'm just a fool. And I'm testing a remove. Okay, you know what? Give me this, this, and this. And let's do this in here. So when we apply our velocity, we need this velocity to only flow on the surface. So we can't sample the nearest normal. We'll use our sample nearest. And let me just check our normal. Okay, that's perfect. And if we join geometry with this, okay, that's good. You can forget this constraint. We don't need it. We'll constraint over here. And we need this to move along with the surface. So we'll take this vector, and let me just remove the radius, 0.1 radius, and let me check again. So this is our velocity. It's right now moving down. We want it to move with the surface, so we will cross product this one with this one. That will produce, of course, both of these need to be normalized. Normalize and normalize. This will give us a vector that is perpendicular to both of these, and we can rotate along our normal and by 90, maybe negative 90. That should be something like this. So now you can see this effect. That's how you know it's working. They are converging to the highest point. We just need the opposite. So let's remove this, and this would be, we don't need this debugger anymore. This would be our new velocity. And for the length, I don't think it should be 1. So the length of this is always 1. Perhaps we shouldn't really do this. Let's see if this works. Okay, it's working pretty good. So they're swirling, they're gathering. And what if I set this normalize? Okay, this is not correct, so we don't need to normalize, and this is already normalized. And this is the effect I was talking about. It wasn't so hard. This is useful if you want to sample something else. So I'll keep it over here, and you can compare the performance. If we get more points, it's 1 meter, and now we have 10,000 points, playing basically real time. And if you use the other method, which is this, the set position with the sample nearest face, and we will disable our effect, you can see how slow this is. You compared to this one. It's just better. And now we don't make clickbaits over here. So 0.5, 0.2, this is 250,000 points. These ones are getting outside our simulation, so these points over here have no neighbors. We should really fix that with our sample nearest. So when we get, this should be clamped. So when we sample the upper point, so we can't just add 40, because when, for example, I have a point on the edge of the grid, and when I find the nearest point to it, I just subtract. So if there's nothing to subtract, it will go to this side of the grid, and this needs to be fixed. So we'll take our nearest, we'll get outside, put it over here, and we'll get our test object again, set this to 4, and let's see, where's my mesh? For now, let me output this one, and let me get this one. So my cell, and first it can be negative, so we will clamp. So maximum, we don't need this maximum, we need the integer one, so a maximum of 0, and this one should be connected over here, and also connected over here. So that's the first problem we have fixed. So there are no negative cells. So this is cell 1, cell 2, cell 27. Okay. Alright. And when my point is, for example, over here, so it can't go over here, we need to clamp that. So we need to cross this point. Okay, we crossed the point on the Y, and let's show the index. So this is 24, 50, 51, 25, 24, 25, 50, and 51, and the cell is 25. This should be 51. This should be 26. So there's no 26. So it should be clamped at 26, which is which one? So the second one or the first one? No, the third one should be clamped at 26. So this one has the maximum. Of 26, which is our resolution. Okay, so it doesn't go above 26, and this one doesn't go to the negative, so fix this corner, and what's only left is this one. So this one goes beyond our bond, and fix this. So the maximum index we have is 650. So let's just go over here. 600, no, not 50, 675. And this one is reading 675, and now it's reading 700. So this one needs to be maximized by this one. We just need to power of 2. Okay, now let's check. Okay, maybe not the power of 2. Okay, this is for the power of 2. How much is that? So, right. So remove this value. So the maximum power of 2, and now this needs to be minimum. So minimum and minimum, and this one is maximum because it's negative, and these needs to be minimum. Okay, now let's check. 176, so it doesn't go above 176. We need to subtract 1. So subtract 1, and okay, 175, it doesn't go above. And the last corner we need to fix, I guess, is this one. So the cell, this one, the one below keeps going. I need to fix that as well. And that one is the third one. So let's check our third. So 26. Okay, seems fixed. And now let's view our simulation one more time, and let's add a bunch more points. So 0.1. So this is 1 million points. Okay, this is 1 million points running 19 FPS. So we have some issues over here. What are those? Did we miss something in here? We might have missed something in here. So let's just disable these and test it. Okay, we definitely missed something over here. I guess these needs to be not in this step, but in this step. We need to put the limits in here. So on the X, it can't go above the designated X. So before we multiply by our resolution, so this can't be a negative. So we'll pick the maximum, and the maximum of 0, 0, 0, and okay, I pressed 9, 0, and 0. So we'll fix some of our problems. So these should be stop leaking. Okay, that didn't fix it. And we need to clamp them also when they go above a certain value, and that certain value is the grid size, I guess. So what this does is move this to be positive, so they can't be above the grid size. Okay, and let's add a minimum and a minimum and another minimum. Let's minimize those two, and now let's test. Okay, that completely broke it. Minimum. Okay. So if it's greater than this, we need to switch to this. Otherwise, we switch to this. And the same over here. So if it's greater than this, we need to switch from this to this. And let's just connect and see. Okay. I will fix this no matter what. So this one doesn't work. Okay. So some of the problem is fixed. We may need to take these outside for better testing. And let's just connect our location. And let's see on our 4-meter grid. Okay, this is the maximum. So tuk 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 tuk. So okay, this goes this way. So 17, 26. Oh, there need to be maxed by the resolution. Minimized by the resolution. Maxed by 0 and minimized by resolution. I was using the wrong scale. Minimized. This one is minimized. So we now know the solutions. Go maximum. And we just need to use this instead of this. So put this over here and this over here. So minimum and minimum. And now, because this is used 4 times, I really hope this works. So 0.2, I have a bunch of points. And let's go 0.1. I have many points. And now they still go outside the bound. What the hell? Maybe this is a feature, you know? So if a point is moving over here, because we're clamping it, so when it's over here, it will have the height of the nearest point because we're clamping it. So clamping it should stop it from making errors, but it will not stop this spilling out. We need to stop it inside our sample nearest. So when we sample outside the bounds, we should scale the position or take only the position of the nearest point that is on the mesh, because this is not a proximity. Okay, does it really bother me so much? Yes, it is. Okay, we have a really cheap calculation for that. Okay, let's try another way. Let's try storing the position. Let's name this P, and we want to store the position of 1 million points. Maybe don't crash my PC. I'll set this to 0.5, and for now we'll get a new attribute, and its name is P, and we'll just go back to the default behavior, and we'll set the position to the nearest position. Will that work? Doesn't work. Or if we add this, so this is the start position. Why does it always not work? So now it's an offset. Doesn't make any difference. So the only one that I found working is the normal trick, which is causing the spill out. And you know what? I'll add another constraint. I'll constrain the position to separate XYZ and combine XYZ, X and the Y and the Z. I will clamp this. I will also clamp this, and it will be named attribute. So size, okay, scale, it's grid scale, add, multiply, and also multiply this one by -1, this one by 1, so from min to max, and also this from min to max. Now I dare you to go outside. What the hell? Oh, this needs to be 0.5. 0.5, 0.5. Now I really dare you to go outside the bounds. Okay. Stay in there. Okay. Let's get more points. Let's remove this test stuff. And remove this test stuff, and we don't need this test stuff. Set this to 0.1, so our million points back. I want maybe to control this damping, so subtract from 1, and I will subtract from 0.02. This would be my damping. And maybe set this to 0.1, we'll see. So now they move really slowly. Of course, there's no any self collision or anything of that sort. So, and we may need to join geometry, and let's join it with our original mesh. So like that. Okay, the join geometry. Man, does it really take that much? It was real time. Okay, there gotta be something wrong in here. I have an idea. Let's duplicate the terrain. Go to the terrain 1, remove this. And now, voila, you have this. See how many points? Yes. Yes. We have points barely going through. That's okay. It's not fully accurate, but it's very, very fast. And one more thing. You may be wondering, Okay, I have a grid and it's 0.2 in resolution, but I don't want to simulate these points. And I get you. You want to add your own points. So I'll go over here and I'll add another empty, or maybe just reuse this one, scale it, and let's distribute points on faces, and maybe not distribute points on faces, but we will get our empty and let's add a random value to its position. This one needs to be -1 and let's scale it, and we'll points, not this one, points, connect this to the position, and 100 points, and we will mark those as store named attribute, and let's mark them, or maybe we'll mark these new points with the boolean as sim, and we'll turn this on. We'll join geometry. So we'll join geometry. Maybe the join geometry will destroy my performance, but we'll see. So let's join 32 points each frame, and these points are spawned inside my empty, and they are joined in. So this may not work. Okay, it's still fast. And when I join these new points, I only want to simulate the new points. So those are my new points. They're simulated. Okay. Do these new points know what's going on? Oh, because they don't have the attributes. Okay. We need to sample the index, and we want to store our 3 attributes. So these, maybe just use the attribute transfer node. I still don't know how to use it, so we'll do it the old way by sample. We'll sample an integer to floats and named attribute. The res goes in the res. The scale goes in the scale. And the cell goes in the cell. So now we add these new points. So we'll set position vector. So we add these new points, and after simulation they stay in the air, which is what we want. Now we'll use this attribute called sim and basically use it everywhere, or not everywhere, only these 2 points, these 2 nodes. So let's use sim, and over here we'll use sim, and the rest of the points will not be simulated. So we should be adding more points, these points. Okay, it's now 4 FPS. And why is that? Because Blender is broken. So apparently you can't add new points. Somehow adding new points is not good. I was just testing, but you can always just simulate your old points or your mesh points, or maybe I can just do this, like distribute points on faces and drawing geometry. And I'm trying something, and these points will have a different radius, which is 1, 4.2, and should be rare. Okay, they can simulate new points, and when I do a distribute points on faces, they inherit the attributes from the faces, so I don't need to sample anything. As you can see, I am not dead. Let's use 12. And how many points do I have now? Well, not much. And let's get more. So this is almost 2 million. Set this radius to be 0.1. And displaying 11 FPS. So not bad, huh? I guess this would be all for this tutorial. See you in the next one. I hope you found this useful and informative. Bye bye.